Welcome to The Explainer. Today, we're unpacking a really massive shift in the industry. Perplexity's pretty bold June 2026 claim that traditional search, well, it's basically broken for modern AI agents. They've rolled out this entirely new paradigm called search as code, and we're going to break down exactly what that means, how it actually works under the hood, and what it signals for the whole future of artificial intelligence. Here's our quick roadmap for today. We'll start with the vending machine problem, then enter search as code, do a quick reality check on the novelty of all this, look at the hidden costs, and finally, wrap up with the real AI moat.
All right, Section 1, the vending machine problem, or why human-era search fails AI. To really fix a problem, we've got to understand the bottleneck first. Traditional search basically acts exactly like a vending machine. You punch in a single query, it runs this fixed, rigid pipeline, and boom, it spits out a finished page of results. That's the human-era contract. And honestly, it's perfectly fine when an AI just needs to read one simple answer. But what happens when modern AI agents need to run these complex, multi-hour tasks? They aren't just reading a single answer. They're firing off hundreds, maybe even thousands of custom retrieval operations every minute. When you try to force that through the old vending machine model, control becomes a massive bottleneck. Language models are amazing at reasoning over context, but with monolithic search, they literally have zero ability to steer how that context is fetched, filtered, or ranked.
Which brings us to Section 2, enter search as code, trading that vending machine for Lego blocks.
To solve this glaring lack of control, Perplexity introduced search as code, or SAC for short. They've essentially turned search into a library of programmable primitives. So let's look at how this is built. The architecture breaks down into three core layers. First up, the model control plane. This is the brain that decides the overall strategy and actually generates custom Python code. Next, that code runs in a secure sandbox. This gives it deterministic execution and, this is key, maintains state across multiple turns. Finally, the model taps into an agentic search SDK. Think of these as atomic building blocks, like little Lego pieces for retrieval, ranking, and filtering that the model can just snap together on the fly. And there's a really brilliant secondary insight here. The code itself acts as a gap filler. If a model needs some crazy complex regex that standard search just can't handle, it doesn't need a bloated SDK. It literally just writes a few lines of code to fetch and filter the data perfectly.
Okay, so what does this actually look like in the real world? Let's check out a case study. The task was to identify and characterize over 200 really complex software vulnerabilities, known as CVEs. Now, each of these had to be perfectly cited to a specific vendor's advisory and tied to an exact fix version.
For a traditional system, a task like that is an absolute nightmare. The vending machine model just chokes on it. But the custom retrieval program, orchestrated by search as code, it scored a staggering 100% accuracy. No joke. The model dynamically fanned out over query templates, it used another LLM mid-pipeline to refine thin spots, and applied a strict schema-bound verifier. Meanwhile, non-Perplexity systems tested on this exact same task, they were hovering way down under 25%.
But here's the thing, it's not just about getting it right, it's about efficiency. Just look at this massive token reduction. By using code to fill the gaps and keeping all that bulky intermediate data out of the model's actual prompt window, search as code slashed token usage by 85%. We're talking a drop from over 288,000 tokens down to just under 43,000. So the model isn't trying to cram every single search result into its head at once. Instead, it's smartly letting the code shuttle the data around behind the scenes.
Let's move to Section 3, a reality check on novelty, impressive engineering versus industry convergence.
Now, the engineering is undeniably impressive, for sure, but we need to peel back the shiny vendor marketing for a second and contextualize how novel this actually is. If we take a closer look at the data, a few things definitely deserve raised eyebrow. Perplexity is touting this massive 2.5x victory over competitors, but that specific number, it comes from their own currently unpublished benchmark called WANDER. And, in data science, whenever an author releases a self-authored benchmark and happens to win by a mile, well, you always want to view that with a healthy dose of skepticism until it's independently replicated. On top of that, the model lineup wasn't exactly an apples-to-apples test. The search as code system was running on GPT 5.5, while the Anthropic baseline it was compared against was using an older Opus 4.7 model. When you're trying to prove a brand new architecture is the winner, keeping the underlying model constant is absolutely vital.
More importantly, the whole concept of keeping intermediate state out of the token stream by using code execution, that's actually a convergent industry idea.
It didn't just magically fall out of the sky in June 2026. This progression really kicked off back in 2024 with the Kodak paper. That paper basically proved language models are way better at writing code than they are at spitting out JSON tool calls. From there, we saw Hugging Face and Cloudflare launch similar concepts. And then, naturally, came Anthropic's Model Context Protocol in late 2025, which explicitly argued for keeping tool definitions out of the context window using sandboxed APIs. So, while Perplexity's search as code is a highly sophisticated, search-specific version of this pattern, the conceptual ground, it was already pretty well trodden.
All right, Section 4, the hidden costs, the trade-offs of programmable search.
So here's the catch, because there's always a catch. Re-architecting the search stack is awesome, but it's not magic. Executing model-generated code at scale brings some severe hidden costs that builders absolutely have to account for. You are essentially trading token bloat for massive infrastructure headaches. Think about it. If you're building an agentic pipeline, a subtly wrong line of code used to filter data can just silently drop critical results. Instead of throwing a loud, obvious error, the system just acts confidently incorrect. Plus, observability becomes a total nightmare. When a pipeline fans out into thousands of opaque little operations, debugging is incredibly complex. And reproducibility? That takes a huge hit too, because every single run might synthesize a slightly different program. Oh, and while you're saving on input tokens, generating all that code adds latency and naturally bumps up your output token usage.
And then there's the big strategic tension. Vendor lock-in. Because Perplexity's custom SDK isn't part of the standard pre-training data for these models, the system relies heavily on what they call agent skills. These are bespoke, highly specific prompts used to teach the model exactly how to use their particular tools. Here's the real issue. The more powerful and idiosyncratic this proprietary SDK gets, the harder it becomes for you to just pack up your agent stack and move it to a different provider.
Which brings us to our final part, Section 5, the real AI moat, and what actually matters for builders.
If this whole code as action concept is just becoming the new table stakes, what actually creates defensible value in the AI world? Well, the real moat for a company like Perplexity isn't their blog post or the general architecture. It's the incredibly hard to replicate infrastructure running underneath it all. It's that atomized search infrastructure they had to rebuild entirely from scratch rather than just throwing a wrapper over an existing API. It's their massive proprietary web index and crawling capabilities. And honestly, the most fascinating part? It's their closed auto-research loops. They are continuously using real-world metrics to co-evolve and tune both the SDK's ergonomics and those agent skills. That continuous feedback loop is the quiet powerhouse driving this entire system.
Ultimately, what this explainer highlights is a massive structural shift in how machines compute. We are moving away from those monolithic one-and-done AI calls and heading straight toward a hybrid form of computing. Language models are handling the token-space reasoning, dealing with all the ambiguity, the strategy, the planning, while hard-coded deterministic runtimes are taking over the heavy lifting of batching, filtering, and parallelism. Search infrastructure isn't just a lookup tool anymore. It's becoming the universal input and output layer into the world's information.
And that brings us to the core dilemma for anyone building in this space. As this programmable, code-driven architecture inevitably becomes the new industry standard, you have to ask yourself a critical question. Is the massive, immediate leap in agent performance worth the long-term cost of proprietary vendor lock-in? Or does the true future of AI rely on an open, universal standard? Definitely something to chew on as you design your next stack. Thanks so much for joining me on this explainer, and keep exploring.